I'm going to show you how easy it is to generate custom embeddings to build powerful AI apps using some really convenient tooling from Supabase. We're going to go through an example using Supabase Edge Functions and the new transformers.js package, but if Python is more your flavor, then stick around because we're also going to check out the new vecs library, providing ChatGPT with additional context to answer questions outside its training data. Let's get into it. Let's start by running npm install -d Supabase to create a new Node.js project and install the Supabase CLI as a dev dependency. So this is just a way for us to lock down a specific version of the Supabase CLI for our project. And we can see we've got our package.json that shows our Supabase package. Next, we want to create a new Supabase project. So let's run npx supabase init. And we do want to generate VS Code workspace settings. So let's say Y. And now we can open this workspace up by clicking on the file and then open workspace. And now we have our project root and Supabase functions as separate folders. So we can treat the node part of our project separate from our Supabase Edge functions, which are written in Dino, but keep all of our project's code grouped together so we can commit it to source control and seamlessly collaborate with others. So let's run npx supabase start to run our local Supabase instance, and we can see that is up and running. So let's create a new Edge function using npx supabase functions new, and we'll call this one generate-embedding. And that will create this Supabase functions folder with this generate embeddings folder within it, and then this index.ts file, which is our new Edge function. So let's import the pipeline function from transformers.js. This is what we're going to use to generate our embeddings. And we also need to import env. Now we can set some configuration options to say env.useBrowserCache equals false, and also env.allowLocalModels equals false. And these are just to switch off some things that are not available within a Dino Edge environment. And now instead of this console log, we're going to create a new variable called generate_embedding and set this to await, as this will be an asynchronous call, which is allowed at the top level in Dino functions. Very cool. So then we can call pipeline, passing the string feature-extraction. So this is the type of inference task that we want to perform. And then the second parameter is the model we actually want to use to generate these embeddings. So that is going to be Supabase/GTE-small, which is a model we have hosted on Hugging Face that has a super low dimension size. So check out the blog linked in the description to learn why a small dimension size is so important. Another thing to call out here is we're invoking this pipeline function outside the serve function. And this is just an optimization for warm starts. So if this function is being called regularly, it will keep this value in memory instead of downloading this model from Hugging Face on every call. Now we can modify our serve function to take in some input, and then we want to generate some output, which is going to be our embeddings. So let's await a call to our generate embedding function that we declared above and pass it our input. We then need to provide some configuration options. So we want to set the pooling to mean, which means embeddings will be generated per sentence rather than per word, and set normalize to true. So then we can create our embedding by calling array.from and passing it our output.data, which we can then send back as the response from our Edge function. So let's serve this function locally with npx supabase functions serve. And now we can use this curl command to invoke our Edge function by updating the name of our function to be generate-embedding, and then replace our name parameter with input and add whatever text we want to create embeddings for. So we can say Supabase supports transformers.js, and now we can copy this curl command and paste it into a new terminal window. And boom, we have embeddings because Supabase supports transformers.js. So next up, we wanted to show off our new vecs library in Python. So let's spin up our Jupyter notebook and provide ChatGPT with some additional context from Wikipedia that it doesn't have as part of its existing training data. So let's install some libraries to help us generate those embeddings. Vecs is something we built at Supabase, and we're passing it the text embedding adapter so it can handle installing some additional machine learning dependencies. Datasets is a convenience wrapper around some open source datasets on Hugging Face, and Apache Beam and this parser are some additional sub-dependencies required for this dataset. So let's load this Wikipedia dataset, and we can see that there is almost 6.5 million records. So probably not something we want to type out by hand. Next, we connect vecs to our Postgres database via the connection string, which you can get from your Supabase dashboard. Then we create a new collection called wiki_collection with the database name of wiki, and then use this adapter to chunk up our paragraphs and generate embeddings using this Hugging Face model for sentences. So now we're iterating over our dataset and filtering it down to just the articles about the Olympics and the year 2022. And you can see from our 6 million records, it's found 44 that are relevant. Now we insert those records into our wiki collection, which generates those embeddings and writes them to our Postgres database, meaning we can then query our wiki collection, asking it to describe the 2022 Winter Olympics closing ceremony. This is including our metadata from Wikipedia and limiting it to 3 results. We can then iterate over these and print out their title and ID, so you can see these articles are very relevant to our query. So let's combine all of those titles and content for each of our articles to provide this additional context to ChatGPT. So we can see this is a whole bunch of additional information. And finally, we can import the OpenAI library and make sure you provide your OpenAI API key. And then for our message prompts, we're telling ChatGPT you are a helpful assistant, and here's some information to be aware of, providing it the context of our Wikipedia articles, and then asking a slightly more specific question, so describe the closing ceremony of the 2022 Winter Olympic Games in 100 words. Again, this question falls outside the training data for ChatGPT, so it wouldn't be able to answer anything specific or helpful without that additional context that we're providing from Wikipedia. We then get this response and generated text from ChatGPT, which knows super specific things like the titles of the performances and when the Olympic flame was extinguished. Supabase makes it so easy to leverage all the amazing work going on in the AI space and supercharge your apps with the power of 1 billion robots. We'd love to hear what you're going to build with this new tooling, so leave a comment below and tag us on Twitter when you need some help amplifying your new AI product. Now, if you want to go deeper with Supabase AI, I recommend you check out this video right here. Thor goes through using Next.js, LangChain, OpenAI, and Supabase Vector to build an AI chatbot trained on custom data scraped from other websites. But until next time, keep building cool stuff.